today I would like to talk, and I would like to remember that it's not a talk, it's not a one-to-many. So if you want to interrupt me, just please do it when you want. No problem. The topic I chosen for today is the runtime polymorphism. That's a talk, not a talk, a collection of talks started, I think, from by Sean Parent. I don't know if Damien you agree on this. I think was Sean Parent in 2000 something 14. I don't know. That started this, and then several other talk had followed. But anyway, it's something related to a very specific topic in C++, that's polymorphic collection. Let's call it like this.
I love this topic a lot. Yeah, definitely.
Yeah. That's an example. This test is our first example. We have this collection that in this case is just a vector of int. So you have we have just aliased the vector of int as the name collection underscore t, and we have instantiated a collection, and we had placed an int number. So here nothing is polymorphic, is just a plain simple C++, and the usage of std vector. For example, and to be, let's say, to be testable in some way and to be something like test driven, we are trying to create this draw function that is accepting this kind of collection, and this is that is writing on a string stream, and obviously at the end you will assert that the value that you have in the string stream is what you are expecting. That's very simple. The draw function here is a free function that is accepting a collection in this specific case, that is accepting a generic output stream and a position. It's not mandatory, but in this case Sean Parent started from this, so I have just included this in this function signature. And internally I have leveraged the algorithm for each. I know it's can be a range for or a normal for, can be everything. It can be a copy also, I think, with a back inserter or something like this. But anyway, just to keep it simple, I have used a for each.
Sean Parent will be proud of you because he say know your algorithms. He say that.
Okay, so I think it's everything we can say about this. I don't think we can say too much. The first step I would like to do is to check out the second branch. So I will not write too much code because I would like to go step by step, and then we will try to do the second modification by hand in a sort of pair programming or ensemble programming. So the first thing we need is to create a wrapper. So the test is exactly the same as before. Nothing changed from this perspective, but the document changed a lot. So let's try to see what is this object. The collection now is not anymore a collection of int, but is, sorry, yeah, have to accept Luciano. Hello, Luciano.
Hello.
So I was saying the collection is not anymore the vector of int, but is a vector of object. And here object is only a wrapper to an int. Let's try to go through the definition, or better declaration of this. You have this object that is that has a explicit constructor that is accepting an int, and is creating a member that is a unique pointer to an internal structure, let's say a private one. Is not that important here. At this point we can just write int, but is I know it's a psychological leap, but yeah, that's a double leap, let's say. But anyway, you pass in an int and you create the unique pointer of for the int. Obviously, this is too much to store an int. Can be done very cheaper than this, a lot cheaper than this, but we need this for a second step. In this specific case, it's not strictly related to this talk, but we normally want to avoid copies, so we delete the copy of this object, and as we have explicitly declared a new constructor, we need to delete the copy constructor and re-enable the move constructor. It's not, I know it's not strictly related to the talk, but if you want to emplace your new object, obviously you need the move constructor. So it's something we need for sure.
Yeah, then my spirit says you have written 4, maybe you're missing the 5th. I mean, are we missing the destructor or not? Anyway, it's not important in this moment, maybe, but just to point that. The rule of 5. I don't know, in this idea, is that useful or not?
I don't think it's useful as far as I put the final keyword here.
Okay.
But
okay, that's fine.
But
okay. So it's fine here.
Yeah, it's useful if you want to your structure to be inherited from. But
yeah. You're right. Yeah. I just seen 4 and what? 5. 5.
Yeah, but in the rule of 5, I'm not sure we have also the destructor. But anyway, it's a different story. Hello, Sylvia. Good evening.
Hello, sorry, I'm still working, so I will follow a bit.
No problem. We have a lot of people from the financial sector that are not present, but that they were in the RSVP list. So I think that you are in a difficult day. So no, don't worry. Just we are happy you are here. Okay. So let's try to go through these. If you need this collection to be polymorphic, and that's not polymorphic yet, you need to create a wrapper, a sort of wrapper. Can be obviously I know that can be an STD variant, or can be an STD any, or can be an I don't know, entity. I don't know if you know this repository is something related to the game programming, and it is an entity component system. But in this specific case, shown parent, I think was in C++ 14 and has no the variant at compile time. Oh, sorry, I got another people from why. Okay, so I will try to continue. So you need a wrapper to your object, and in this specific case, this wrapper is this object, object T, with the polymorphic function you need. So if you need the draw function to be polymorphic, so if you need this draw function to accept different kind of object, and of course this same collection to accept different kind of object, you need to explicitate this draw in a polymorphic way. So here you have the generic template draw that is accepting everything, let's say almost everything, and is accepting a no stream and a position sides T, and we will have this the implementation for this generic that is just for everything that can be just redirected to the O stream, and we need this specialization of the template for the specific type collection T, because the collection is something related to several objects, so we need a specialization. Is the std vector has no operator, yeah, let's call it redirect. I don't remember how to call it this operator, but anyway, so this operator is missing for std vector, and so we need to define this. Here I use the range for, so it's not that good, but anyway, can be good also. Okay, so up to now nothing happens new. There is nothing new. We can just try to do the next step. This can be our next step. Obviously here we can do like this, I think. Okay, and we can try to add this to our collection. Okay, obviously something is broken, and why this is broken is it's because we are passing a string, but the object T is expecting a string, so that's something not good. And also the model T is expecting an int, and also is a wrapper, a second wrapper, private wrapper for an int data. So everything is related, till now everything is related to int. Now what's the language facilities that can help us, as the talk that I will link in the comment later on, or maybe next week, earlier next week. As in this talk, the language facilities obviously is the template. So we can change this function from int to accepting a type t, and here we can use move or perfect forwarding, as we already said with Damian last month. But anyway, we will try to do a new talk related to this in the next weeks. And now I think it's still broken. Everything is broken because also here we need this template. And here we need t, and here we need t. And here, this model, we have a problem because the first thing that comes to our mind is to not have the constructor template, but all the object template. But that's normally, let's say, normally not very good. It's good for a lot of application, but not in this case. So the thing that we can do is to create what Sean Parent call a concept. And here I agree with Matteo, we need obviously the destructor first of all, because this is meant to be inherited, and we need these. And we need here an override because we want to inherit from concept. And here we can create a unique pointer, not for model but for concept, because it's internally can be managed polymorphically. Let's see which kind of big errors I did. Who can spot the error? Let's check. Not matching function. I think it's because model T is a template, so I have to specialize or to define which kind of template class you need, and here is a template constructor, so I can create it.
Don't you need to add a type name in front of T in this context?
I don't think so. I'm in which compiler I'm using, GCC, and never asked me for type name.
Okay, no, perhaps it's just I really want to instantiate the T that you have at that time. Yeah, sorry.
Yeah, no problem. Hello, Luca.
Luca Barilla, non ci credo. Guarda che c'è.
Hello. Yeah,
Hello.
we have time later to to debriefing.
Sorry. Yeah.
Okay, so here we have something that is actually compiling. I'm not sure is also running. Let's try. Okay, and it's failing. Why it's failing? because I didn't put this string in the assert. So the test was broken. Let me check if it is right. Yeah. So now we have a collection that is accepting a string and is accepting an int. The same collection, the same alias of std vector of object t. This object is acting polymorphically. So now in the presentation we have a couple of things to talk about. I don't know if up to now there are questions, or we are very open to discussion here. It's not as I want to remember, is not a one-to-many. You can interrupt me any time, or you can propose any kind of discussion about this topic.
This thing from Sean Parent, actually, is it that is used as in boost type erasure? Because it looks like to me that it's really similar to how boost type erasure is built. And I imagine perhaps boost type erasure was made then inspired by what Sean Parent did. And the other thing that at the moment, personally, another question I have, is just shoot both, is you made a strict concept, and that's the thing also in boost type erasure. They have like concepts for as struct. Is it not possible nowadays with actual concepts to do something that would be like runtime polymorphism and like, but based on C++ concept? I couldn't take the time to like sit in front of my computer some hours to think about it, and I wonder if you already I thought about that.
I'm not exposed to C++ concept till now.
Okay.
So
okay.
I don't know if we are in the embedded space. We are not used to stay on the top of the standard, so we are still on the 11. If we are lucky, on the 14, not more. So that's why I use this almost plain C++ 11. Yeah, I think yes. Maybe something somewhere is not strictly 11, but anyway. And the first question, I didn't get it. The boost type erasure.
Yeah, it's just that the boost type erasure library seems to be like framework to do what you do, and they also have this as self and so. And it looks like to me that I think the boost type erasure has the same implementation under the hood as what you are doing. I imagine but I cannot assess it right now, and that was my point. I didn't know. I wanted to ask if you knew or
no. I don't know. Actually, I would add this in my to-do list. Check
cool.
boost type erasure or something like this. Erasure.
Yeah.
Okay, and also we have we have many talks in that years from 14 to 17 that are related to this type erasure. So yeah, maybe I can find something very very similar to this in some other talks. And there is.
I think what did he's named he's also working at Bloomberg. I think at the moment, Louis Dion. I think he did something like his name Poly, and I think it goes also in this direction. But this is only for newer standard. Boost type erasure, I think it works in C++ 03 already.
Okay.
So yeah, just asking because I have also been the first time we had the meetup, I shared some code from NDG that was using a template static variable. To do such kind of things actually, and I think when you combine all this stuff, you come to something wonderful at the end.
Mm-hmm.
And I made a talk at some point inside a company in the past about that. I could the next meetup I could use it so that we could compare the approach, or at least taking 5-10 minutes or so.
Yeah. That's that's a good point. Yeah, I think it's if you have a STD variant and you just want to have everything at compile time, maybe the best choice you have is to go with an STD vector of STD variant of your pool of types. But if you don't know, for example, if you are writing a library, this is a very good approach because you are letting your library customer, your library clients, to add their own types also. Obviously, if you are writing another library, another only library, you can also add your STD variant at runtime, no, at compile time, sorry. But in this case, that's really good because I feel, that's my feeling, that is really good because if you want to add, for example, let's say n, just to create a name that is not understandable, new type t, and here you have a new struct with new type t. That's the first time I'm doing this, so maybe we are not going anywhere. We are going nowhere with this, but anyway, if you have a new type, you can, at some point, you can just try to add this new type. Yeah, let's do it easier. Okay, here is the same problem. It says, the compiler says that new type t is not derived from anything, from, for example, std string or int, is not stringable. let me say, call it like this. But the interesting thing is that if you define the partial specialization, or maybe also the operator less than, you can just, I think, do something like this: out new type t let me check if it is working. I'm not sure because it's, as I said, it's the first time, and we should have the test failing. Yes, and here we should have new type t/n. Yes. So I think it's very useful from my side because I have in my former job I have a lot of home devices that have many APIs, public APIs, very similar among them, and I just tried a lot of time to do a polymorphic collection, and only lately, earlier this year, I discovered this talk from Sean Parent, and was like an open eyes talk for me. And this particular thing is very important in my case because I would like to add my new type and to define the way they act in very easily to the collection. the point here, and I just miss, I just need to couple of minutes more. The only problem here I see, that's a very important problem and very important limitation to this, is that the polymorphic object should be really polymorphic. So they should have very similar behavior. Otherwise, if you, for example, if you add this one, let me check if Jimmy, who is Jimmy, I don't know, but anyway, let's try to keep it him inside. For example, if you do switch and sorry, and you have for example do color levels. For example, if you have a light bulb, obviously the light bulb can switch on and off. But if you have a white light bulb and you have a color light bulb, the light bulb can switch on off and can change color, but the white light bulb cannot change color. So at some point you have some implementation that is just empty, and I think that's the big limitation of this approach. If you have objects that does a very limited that have very limited behaviors and very different behaviors, this approach cannot work for you. Should be a real polymorphic collection. There is nothing, I think, that's my feeling, but I am ready to have a different position from you. I think that the polymorphic, a collection of objects in the most cases in the computer science should have this behavior. So should have the most of the behavior very similar among them. And otherwise, it's just a collection of pointers to very different objects. And the other things, so this is a very big problem to me. If I want to put in a single collection lights, shutters, and fridge, and something very, very different, HVAC system, this is not the solution, obviously. I would have the same problem as before, and I need for example, a collection of lights, a collection of shutters and things like this. The thing that is very good here is that you are exposing a value semantics. So your customer, your clients are not using pointers in any places. Everything is inside your implementation, and you are in charge of making sure that everything is done correctly on your side, but the client can just use plain, straight objects without taking care of anything related to the pointers, to the heap allocation, and things like this. That's everything from my side. I don't know if I hope that the main messages are passed to you. I don't know if some of you have some questions.